Alright, so right here, local newspaper, it says the population in 2012 is 130,457. That goes for A, our initial, 4% each year. Change that to a decimal, be 0.04. Move the decimal twice, it'll be 1 plus 0.04 because it says growing, so that'll be adding instead of subtracting. Notice it says plus and minus here. So that'll be 1 plus 0.04, which will give me 1.04 raised to the t, and you'll have your initial value of 130,457. And they're multiplying, so that parentheses, same thing as the multiplying up there on B. And here it says population of 4 rabbits into a wildlife region. The population doubles each year for 5 years. Which of the following graphs represents situation? Here, notice it's A because it's growing. Notice that's at 5. It's growing up. The rest of them are linear. Well, except for this one. This is growing. They're decaying. But that's exponential because our equation there would have y equals 4 times 2 raised to the x. So that would be growing upward and it's exponential. Number 3. Trying to find the sequence here. See how it's increasing, multiplying, or adding and subtracting. Look right here. I'm going to plug in our values. So when you have multiple choice, so right here I plugged in the 3. Right here 2 to the third is 8 plus 1 is 9. 2 to the fourth plus 1, 16 plus 1 is 17. 2 to the fifth is 64 plus 1 is 65. 2 to the sixth plus 1 is 128 plus 1 is 129. So we notice all those match up, so our answer is C. If the graph of 4x is shifted 5 units to the left, what would be the equation? Right here, that one's not possible because it says minus 5. Notice that the h value here tells me left to right and it's opposite in the sign. So our equation for this would be y equals 4x plus 5, and the next one will make it go left 5. So it's always opposite. What is the rate of change for the function f of x equals 5 times 2 raised to x over 4 over the interval 8 to 12? So right here we're going to plug in 8 for x. 4 divided by 8 is 2. So 5 times 2 raised to the second power is 20. That's 8 is 20. So our order pair for that would be 8, 20. And that'd be x1, y1. And then we plug in 12 for x. And put 12 right here. Divide 12 by 4, get 3. 5 times 2 to the raised to the third power is 40. Get 12 and 40. Be x2, y2. Then we're going to use our slope formula to find our average rate of change. So we do y2 is 40 minus y1 is of 20. And x2 of 12 minus x1 of 8. And you end up with 5 as your average rate of change. Number 6, given the graph f of x below, what is f of 2? So that means the x value of f of 2. Right here, 2, if you go up, you'll see it crosses at 6. 2, 6, so our f of 2 equals 6. Which explicit expression, the pattern in the table below? Right here our equation is a sub n equals a sub 1, which is the first term. And then r, which is the rate. So our rate here is multiplying by 7 on the way up. Because negative 5 times 7 is 35. So notice it's multiplying. So that's my rate of 7. And my initial term, my first term in this sequence is negative 5. So that's going to go in the front. Alright. Population of squirrels doubles every year. Initially, There were 5 squirrels. A biologist studying the squirrels created a function to model their population growth. PT equals 5 times 2t, where t is the time. Graph of the function is shown. What is the range of the function? So our range, remember, is dealing with the y values. So right here, we know a is our initial value. So we know that'll be 5. So you start at 5 squirrels. Starting point is your y value. So you see right here, we got 5 squirrels. And it increases. Alright, and we know that squirrels are whole numbers. So it increases with each squirrel. So it's going to be any whole number greater than or equal to 5, because you can start off with 5 squirrels. Alright. Right here, what bounce was the height at 10? So look at your graph and figure out which bounce with the height is at 10. Right here, it's at 1 bounce, the height is at 10. So you follow right here, you got 10 bounces. 10 for the height and 1 for the bounce. Notice it has bounces and height. What's the formula for geometric sequences? A sub n equals 3 times negative 2 raised to n minus 1. What is the 5th term in the sequence? Here we plug in 5 for n. 5 minus 1 is 4. 3 times negative 2 raised to the 4th power is 48. Squeeze juicer company allows trade value, VT, of the commercial juicers within 6 years of purchase according to the function defined below, where T is the number of years that have elapsed since the machine was purchased. What is the domain of the function? Right here it says the commercial allows trading value from 0 to 6 years. It says T is the number of years elapsed since the machine has been purchased. So right here we know that the T is the amount of X values in the domain, because VT is the Y value, so we know it's from 0 years to 6 years, and you allow trade value. Okay. Find the average rate of change of the interval 0, 2 for both equations. Which statement is true for the average rate of change given the interval? So this part is equation A, and this is equation B. Find the average rate of change over the interval 0 to 2 for both equations. So right here, from 0 to 2, every time it's going up by 2. And if you're going to find it from 0 to 2 here, it'd be from 1 to 4, so you could do it from each one. But right here, we could also do it y equals 4 raised to the x. Alright, because if I go from 0 to 2, it would be times 4. In equation B, if I go from 0 to 2, it will be, so right here, we're going to go up 9, well it's really 8 over 2. And y equals 4 to the x. So actually our average rate of change for this one is going to be, they're equal over that interval. So the rate of change for both of those will be equal over the interval 0 to 2. Now I did it earlier and did it over each one, but it's not each one. It'd be times 4 from 0 to 2. And then right here from 0 to 2 is 8 over 2, which would be 4. So they're both to the 4x. Alright. 13. The below represents the function. Which of the following represents this graph? So we're looking at this function. How does this equation or function change this graph? So which one has been transformed? Right here we see that minus 2 moves it down 2, and our asymptote would now be negative 2, and it would move the points down 2. Notice right here you can see 1, 2 going down. Find the fifth term in the following geometric sequence. Right here, you're going to have to figure out the rate in order to find the fifth term. So our fifth term in this sequence, you're multiplying by 5 each time. So we're going to multiply by 5 to get 375 for the fourth term. Multiply by 5, get 1875 for the fifth term.